Alright, so after exam 2, we will focus on 2 topics left, which is the time series and the data mining. Alright, so with the limited time, it is not possible for us to get deep in the details, but at least you need to get the general idea about what is the time series, what is the general idea of the time series, right? And also with this kind of time series, how you can make the prediction, how you can do the forecasting, how you can make the estimation, right? And you just get the general idea about the time series, right? So for the data mining, it's even kind of the largest topic in statistics, so it is not possible to be done within just 4 classes or even 2 classes. So still you need to get the general idea so that you know what is data mining, what topics will be covered in the data mining, why we call it is data mining, something like that. And of course, in these 2 chapters, we will have some detailed calculations, but you will have the directions, right? You will have the steps given to you. So I don't think the calculation will be hard, but I need to say the calculation is harder than the regression part, right? And I think it is also harder than the previous chapters because it is not hard in the calculation, it's hard in understanding and make sure you don't have any mistakes. Right, so don't get scared, right? So let's get through them together and figure out. All right, so I think some of you may heard about this time series for many times in the newspaper or somewhere else, right? But what is exactly a time series? Right, so the definition of time series is whenever the data is recorded sequentially over time and the time is considered to be an important aspect, we call it is time series. Or we say more generally, we say if this y, which is the response variable, is recorded over time, then we call it is time series, right? So for example, this Whole Foods quarterly sales, right? So actually we record the sales for every quarter, right? So that means within 1996 we have 4 seasons, right? And then for from 1996 to 1997 we still have 4 of them, right? So actually this plot, kind of the scatter plot, will show you that this data is recorded by the time, right? So here is by every year or every quarter. So it is not limited to year or quarter. It can be any time, right? So the y can be recorded, let's say, every minute, right? Every second. Let's say every 2 days, right? Or let's say every day, which should be daily, right? The y is recorded daily. And then, for example, every month, so will be collected monthly, yearly, right? So all these ones, as long as the y is recorded over time, it is called a time series. All right, so for the time series, most of them are equally spaced at roughly regular intervals, so such as monthly, quarterly, annually. So actually you cannot just randomly choose 4 months in a year and then just record 4 points in a year. You need to have equally spaced, right, for the regular intervals. All right, so here will be each quarter, right, each minute, each second, each day, every 2 days, but we have the same interval here. All right, okay. And then why we have a time series? Of course, as I said, in statistics, our goal is always to make the predictions. All right, so here for the time series, we kind of not provide we only focus on the future values instead of just within this interval. Right, remember that when we do the regression, we make the prediction in the value in this x interval, right? But for the time series, since we already had these values, so you don't have anything to predict within this range. So actually the goal is to make the prediction for the future values, maybe not far away future, but will be nearby future, right? So to make the difference, most of the time we call the prediction the forecast, not the prediction, right? To make the difference, but it is okay if you also call it is the prediction. That prediction, yeah. Right, so just another name for the prediction because it is for the future values, so we call it is forecasting. All right, okay. When we talk about a time series, we first look at the shape of this time series. All right, so this shape will contain 4 different components. Right, it will not be, for most of the time, it will not be all of these 4 components, but at least not at least one. So you don't know whether the time series will contain any components, but totally we will focus on these 4 aspects. All right, so the first component we look for is called the trend component. So what is the trend component? The trend component is the overall pattern in the plot of the time series. Right, so actually this is our time series, right? And then based on these points, you kind of can draw a smooth line that is increasing, right? So for this case, we say overall trend. We have an overall trend to be positive or increasing, right? So we call it is a increasing trend. So if you see an overall pattern either increasing or decreasing, then we call this time series has a trend component. All right, okay, so this is the trend component. This is the opposite example, right? So for this case, if this is the time series, is there an increasing or decreasing trend? No, right? So overall, there's no increasing or decreasing trend. So there is no trend component. Right, so for this time series, there's no trend component included in this time series. Right, so for this kind, right, so you cannot see it is increasing or decreasing. It is kind of keep constant about this line, right? So it's going down, it will come back to this line, and then going up, come back to this line. All right, so for this case, we call it is stationary in the mean. That means it kind of keep the constant mean. It doesn't matter how far away you go, it will always come back to this line. Then we call it is stationary in mean. Right, so here you just need to know that if I give you a time series, you can figure out this time series has the trend component or doesn't have the trend component. It has the increasing trend or decreasing trend. All right, so I think this component is easy to see. All right, so next we'll talk about the seasonal component. So what is seasonal component? From the name of this component, we look for what? We look for the seasonal pattern. Right, so seasonal will be 4 seasons per year, right? So for this time series, right, so it is what? It is the Whole Foods quarterly sale, right? So for this one, it will be 4 quarts for each year. So it is selected for every season, right? In the end, we want to see that whether for each year, within each year, do they follow the same pattern? Yes or no? Yes, right? So they kind of follow the same pattern that the first quarter is larger than the other 3, 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 right? So the first one, second one, the third one, the fourth one. So they kind of follow the same pattern within each year. All right, so if you see a stable pattern within each year, then we call this time series has the seasonal component. But if you cannot see any stable pattern within the seasons within the year, then there's no seasonal component for this time series. All right, so for this time series, of course, it has the increasing trend, so it do have the trend component. And then for within each year, it follows kind of stable pattern, right? So for this time series, it also has the seasonal component. All right, so let's look at another example. Right, so this example is for the Home Depot sales. It is also collected for 4 quarters for each year, right? So here the x-axis is not for the year. This is labeled as the first quarter, the second, the third, the fourth, the fifth, sixth, seventh, eighth, something like that, right? But it is also collected by quarters, right? Then you will see that it also follows the stable pattern. All right, so for this case, it also has the seasonal component. Right, so you may ask that it doesn't look exactly the right pattern, right? So for this one, the difference is smaller here, but the difference here is bigger. But as long as we say pattern, we didn't say exactly the same, right? So as long as they follow the same pattern, then they have the seasonal component. We do not require them to be exactly the same shape. All right, okay, so this is about the seasonal component. And here we have 2 actual concepts. The first concept is sometimes in the research you will see this word. It is called deseasonalized, right? So what does that mean? It means sometimes the seasonal component is not easy for us to model, to make the regression, right? So sometimes before the regression, before we do something to model this time series, we want to remove this seasonal component. All right, so when this seasonal component was removed, then the removed time series will be called the deseasonalized time series, or sometimes we also call the seasonally adjusted series. All right, so this is just a concept. You know, whenever you see this one, you know it is a time series after removing the seasonal components. It's okay. All right, okay, so next one is about the period. All right, so what is the period in time series? All right, the period is defined as the time between peaks of a seasonal component. So here it is very strict in this definition. So here, what is the period? This period will be the time between peaks of the seasonal components. So it will be the peak here, the peak to here, peak to here. So that means the time between the peaks will be 1 year, right? So this is just a 1 year for seasonal component, right? So the period will equals to 1 year for the seasonal component. But what if the pattern is not happen just within 1 year? What about I have the period which is the pattern happens, for example, every 5 years, right? That means the pattern repeats for every 5 years, then it will not be the seasonal component, right? Because the seasonal components will be the repeated pattern within 1 year, right? So for this case, we have another component to be considered. We call it is cyclical component. All right, so what is the cyclical component? It will be regular cycles in the data with periods longer than 1 year. So just as what I said in the last example, the pattern repeats every 5 years. That means your period will be 5 years, right? It is longer than 1 year. Then for this case, if you can find this pattern which is larger than 1 year, then this time series will have the cyclical component. All right, so we will talk about this later in this chapter, but here I just want to give you some general idea about the cyclical component. So for the cyclical component, it is a very popular research area in the time series. For example, for the to find the credit cycles, right? So it will not be within 1 year, it will be more than 1 year, right? So sometimes it will be 20 years, right? But to model this cyclical component, it is most of the time is hard, right? So here in the later this chapter, we will try to model the first two components. Trend component, we can use the model to model it, and seasonal component, we can also find a way to model this seasonal component. But the cyclical component, it is hard for you to generate the model for now, but I'm sure you can learn more in the future classes. Right, so for our class, we will not model the cyclical component, but at least given you the time series, for example, for this time series, you need to know that whether this time series has the trend component. For this case, yes, right? Seasonal component, yes, right? So you have the pattern within years, right? And then do you have the cyclical component? No, because the pattern happens every year. That means it will be seasonal component, not cyclical component, right? So as long as you can identify these components, will be okay. Right? We will not learn about how to model the cyclical component, right? Because it is a very complex topic. All right, and then the last irregular component, right? So from the name of this component, it is called irregular component. That means it is not regularly happen, right? That means you cannot find any pattern, or you cannot find any way to model it. So for example, for this time series, right? So you see the random fluctuation everywhere, right? But actually you cannot find any way to say it follows a pattern, right? So the points just keep jumping, right? So for this case, it will be called irregular component, right? So actually irregular component is just for random fluctuation. Right, so if you see a time series that's something like this. All right, so my question is, does this time series have the trend component? Yes, right? So overall, it has the increasing trend. Right? Does this time series has the seasonal component? No, right? Because it doesn't have any pattern within years. Does this time series has the cyclical component? No, because you even cannot find the stable pattern for more than 1 year, right? And there a regular component for this time series? Yes, because you can see many random fluctuations over the trend, right? So for this case, it will have this time series has the irregular component. So again, there's no way to model this component. This is just because of the random error. So here, when you model the time series, is kind of just the residuals, the random error, which is this term, or the E, which is this term, right? So it is not possible to model the residuals or the random error, but at least you see some random fluctuations here. All right, so here just another new concept, which is the stationary invariance. All right, so remember when we talk about this, the trend component, we have this. That means the points are just come back to a point, to a line. Whenever it is far away, it will always come back to this point, right? So for this case, we call it is stationary in mean. And then here we have another concept, right? So here we call it is stationary in the variance. So what does that mean? That means it doesn't matter how it doesn't matter, let's say for this case, right? So for this time series, is this time series stationary in variance? The answer is no, because what? Because it has the bigger variance here, smaller variance here, right? So the stationary invariance, it means it will keep the same step, the same height of jumping over the trend. All right, so you will not see this kind. For example, if I have a time series like this, you see this, right? So it doesn't have the constant mean, but when they have the trend, overall trend, then this random fluctuation have the same kind of stable jumping steps, right? It will not go far away and then come back. It will always go a little bit distance and then come back, a little bit distance, come back. All right, so for this case, we call it a stationary invariance. So as long as you got the idea, it will be okay. All right, so you will learn this a lot in the future classes, but not in our class. So for our class, I just want to just give you the general idea. What does that mean? All right, so actually for a time series, what we want to look for, we want to look for the overall trend, which is the trend component, right? We also want to look for the seasonal patterns. Is there any stable seasonal patterns within years, right? So it will be seasonal component. And also we want to look at whether there is long-term cycles, which means the period is larger than one, right? Longer than 1 year. The pattern repeats every 5 years like that. Then it will be cyclical component. But we do not want to or we say we are not looking for the irregular component, because this is a part we really hate, we really don't want, because it is just out of our control. All right, so let's do an example here. Right, so this is a time series, and the United States Bureau of Labor gives the outputs per hour labor and outputs per unit capital, right? So of course it is labeled within over the time, right? So of course it is a time series, right? So now the first question, describe the trend component, right? So here, do we have a trend component for this time series? Or the answer is no, right? So for the trend component, we do not have the trend component, because what? Because for trend component, there is we look for overall trend, right? So overall, there's no increasing or decreasing trend, right? It will keep kind of the same thing. It will come up and then come back, come down, come back, right? So overall, there's no increasing trend or decreasing trend, right? So there is no trend component for this time series. All right, so next question. Is there evidence of a seasonal component? So what is the seasonal component? We say, is there any repeated pattern within years, right? So you see that from here to here is 1990 to 1995, right? So if we divide it into 5 years, right? So that means this small distance will be 1 year. That means correspondingly it will be this part, right? Okay, is this part or this pattern repeat every year? Of course not, right? So again, there's no seasonal component, because what? Because there is no stable pattern within each year. Right, so remember the seasonal component is the pattern within years. All right, and then the next question, is there evidence of a cyclical component? Yes or no? Think about it. Is there any cyclical component? Is there any pattern repeat every more than 1 year? So actually you see that this one, this pattern, right? So this pattern actually repeats every kind of 5 to 8 years. I think it is kind of 8 years, right? So this pattern repeats every 8 years, about 8 years, right? So that means this 8 years is larger than 1 year. So for this case, yes, there is a cyclical component. Because what? Because this kind of pattern repeat every about every 8 years. It doesn't matter it's 8 years or 9 years, but at least I see some repeated pattern that is over 1 year. Alright, so we will stop here for the first video, and you should get some general idea. If I give you a time series scatter plot, you will know whether this time series has the 4 components for each one. Alright, so you need to decide whether this time series has the trend component, whether this time series has the seasonal component or cyclical component, a regular component, right? So sometimes a time series has only 1 component, sometimes the time series has all these 4 components. Some of them may have just 2 components, right? So depending on what kind of time series you have, you need to decide which component it is contained in the time series. Alright, so next class we'll talk about how to model the time series. I will talk about the 2 methods, which is the first one will be the smoothing method, the next one will be the regression-based modeling method. Alright, so next class we'll talk about the first method, which is the smoothing method. Alright, okay, so see you in the next video.